Okay, while others are joining, let us start with a small revision of what we did in the last class. In the last class, regarding your moment of inertia, you learned about a theorem which is called as the perpendicular axis theorem. And perpendicular axis theorem says that if you have an area, any area, let us give it some thickness also so that we can visualize it in 3 dimensions. So this is a very thin area. The thickness is almost negligible. We can call it as a simple area itself. And an axis is given which is lying on the area itself. Let us call it as x-x axis. It's not necessary that you have to always call a horizontal axis as x-x. You can give any name to your axis. For example, just to prove what I have said right now, let me give it a new name. I am giving the name as AB. So AB is an axis which is lying on the area itself. Then I draw another axis, again lying on the same area, but in such a way so that it intercepts the previous axis AB perpendicular to it. So let us give a new name to it. Let us say this is CD. So axis CD is perpendicular to axis AB, and both of them are lying on the plane of the given area. And now, through the intersection point of these two axes, I draw another axis, but in such a way so that it is perpendicular to the plane itself. So as you can see, this axis is passing through the area, but through a point which is already the intersection of axis AB and CD. And since a third axis has been introduced, let me give a new name to it, and now let us call it as ZZ. Now, perpendicular axis theorem says that if the moment of inertia about AB is known to you, the moment of inertia of the area about CD is also known to you, then you can simply say that the moment of inertia of IZZ will definitely be the sum of moment of inertia AB and moment of inertia about CD. And how does this come to be? Axis AB is perpendicular to axis CD, and axis ZZ is perpendicular to both AB and CD. This is the condition. And apart from that, ZZ should pass through the intersection point of AB and CD. If I draw another axis which passes through some random point and still is perpendicular to the plane, and let us say I name it as Z dash, Z dash, then you cannot say that the sum of moments of inertia about AB and CD will also be equal to the moment of inertia about ZZ. Why? Because ZZ axis is not passing through the point of intersection of AB and CD. So if a condition like this arises, you can apply the perpendicular axis theorem. This is what we studied in the previous class. Now a very simple 2 marks question can be given to you in your examination. Look at this problem. For a circular area, prove that IZZ is equal to pi d raised to power 4 by 32.
सर ये पिछले लेक्चर में बताया आपने दोनों का एडिशन कर देना कुछ
हाँ, अब देखो ये मैंने आपको पिछले क्लास में पढ़ाया भी था, या एक बार ब्रीफली आपको मैंने समझा दिया था. Let us see. There is some lag in this software. Let us use another software. A circle is given to you. A perpendicular axis is drawn. It is passing through the centroid, and this axis has been given the name Z, Z. And it has been asked of you to prove that IZZ is equal to pi d raised to power 4 by 32. Now the trick here is to use the perpendicular axis theorem. We know that if you draw a circle and through the center, if you pass a horizontal line and name this as axis xx, now this axis is lying on the circle itself. So in this tilted figure, it will look somewhat like this. This will be your xx. And then you draw another line on the circle perpendicular to your previous line xx and name this as axis yy. So in this tilted figure, it will look somewhat like this. So this is axis yy. And since both axis yy and axis xx are centroidal axis lying on the circle itself, so I can say that Ixx must be equal to pi d raised to power 4 by 64. This is a formula that I had asked you to learn by heart. And similarly, this same formula will be applicable for Iyy also. And now, applying the perpendicular axis theorem, since ZZ axis is perpendicular to the area itself, and XX and YY are lying on the area and are mutually perpendicular to each other also. So eventually this brings us again to the same setup. ZZ is passing through the point of intersection of XX and YY, and both Ixx and Iyy are pi d raised to power 4 by 64, and perpendicular axis theorem in this case again dictates that Izz being the polar axis, and Izz therefore also can be called as polar moment of inertia. But perpendicular axis theorem says that the polar moment of inertia about an axis passing through the point of intersection of two other axes which are lying on the area itself and are also mutually perpendicular to each other, then Izz would be given by simply Ixx plus Iyy. And since Ixx and Iyy are both the same quantity, pi d raised to power 4 by 64, I can say that my Izz would be twice of pi d raised to power 4 by 64, and that will give you pi d raised to power 4 by 32. So this is a very small proof. All you have to do is draw a figure like this and just write this equation, that Izz is equal to Ixx plus Iy, and put this equation in perspective, that this formula is already known to us, and then substitute it here and say that Izz comes out to be equal to pi d raised to power 4 by 32. And this is a very important result for your strength of materials also. So from now onwards, you always remember that the polar moment of inertia of a circular area is given by pi d raised to power 4 by 32. The polar moment of inertia. This is the polar moment of inertia of a circular area. You remember it by heart now. So area moment of inertia of circle about an axis passing through the center of the area and lying on the area itself is pi d raised to power 4 by 64. But the polar moment of inertia of the same circular area of an axis about an axis passing through the center will be half of it, that is pi d raised to power 4 by 32. Now, to practice this thing that we have learned in a more perfect way, let us do a small problem. The problem is a rectangle is shown to you in the figure here. X axis is shown, it is the centroidal axis passing through the centroid of the rectangle. Y axis is shown, it is also passing through the centroid. The dimensions of the rectangle are the width is 1 meter and the length is 2 meters. Find IZZ. IZZ is the inertia of the area about an axis ZZ which is perpendicular to the area itself. Look at the figure. Now what you have to do is find the value of IZZ. Now as you can see, again perpendicular axis theorem is applicable here. ZZ is perpendicular to the area. XX and YY are both lying on the area and are mutually perpendicular to each other also. The moment of inertia formula for rectangles, as you remember, is BD cube by 12. The only thing is you have to remember which side has to be cubed and which side has to be left as it is. So if I take up this triangle, sorry, if I take up this rectangle,
सर
हाँ
इसका आंसर 0.66 होगा ना?
देखते हैं, अभी तो बेटा मैंने भी नहीं निकाला, ये अच्छा है आपने पहले निकाल लिया.
मैंने सॉल्व कर लिया इसलिए.
वेरी गुड. एक बार अपन इसको ध्यान से देख लेते हैं so that everybody understands how to do it. This side is 1, this side is 2. Okay. Now tell me what will be the moment of inertia about x axis, that is ix.
by 2.
According to the formula, it will be 1 into 2 cube by 12. Since x axis is cutting the side 2, so the cube will be of side 2. Now what will be the moment of inertia about axis yy? Now as you can see, the side that is being intercepted by the axis is the one with length 1. So Iyy will be 2 into 1 cube by 12. Now, if the z axis is perpendicular to the area itself and passing through the point of intersection of the previous two axes, which are also mutually perpendicular to each other, in that case you can apply Iz. हाँ
सर इसके आंसर में मिस्टेक हो गई थी तो 1.16 होगा शायद.
हाँ, अब ये जो मैंने आपको यहाँ पे लिख के दिखाया है Ixx और Iyy, इनको देख करके आप आंसर करेक्ट कर लो. ठीक है.
Yes,
So
sir.
Izz will be simply equal to Ixx plus Iyy. That's all. Okay. This is the perpendicular axis theorem that we learned in the previous class. Now let us start with another theorem which is called as parallel axis theorem. Now what does parallel axis theorem say? The proof of parallel axis theorem is given over here. This one is parallel axis theorem. The statement I will explain to you. The proof I have given for you, and I will not be discussing the proof. You have to study it yourself. I will explain it and we will use it in our calculations. Now let us go back and see what parallel axis theorem says. Parallel axis theorem says that if you have any area, so since any area is allowed, I am taking a simple area, that of a rectangle. And it says that you know where the centroid of the area is. Okay. And you have been given an axis which is passing through the centroid. So that means you have been given a centroidal axis. And since for now the centroidal axis is vertically placed, I choose to name it as YY. But as I've already told you, you can choose to name it in any way as you like. But a vertical axis is intelligently it's easy for us to decide that we can call it as YY. So let us call this YY. And this is a centroidal axis. And somebody gives you another axis, let us say we name this as AB. And additional information about AB is given that axis AB is parallel to your YY. So if this condition is met, that an axis has been given which is parallel to your centroidal axis. But please remember, for parallel axis theorem, the necessary condition is that the previous axis or the first axis should be the centroidal axis. ये कंपलसरी कंडीशन है. सेंट्रॉइड से पास होने वाला एक एक्सिस तो होना ही चाहिए और एक दूसरा एक्सिस और दे दिया जो कि सेंट्रॉइडल एक्सिस के पैरेलल है. In that case, the moment of inertia of your area about the second axis AB can be simply given as the moment of inertia about the centroidal axis plus area of the rectangle, that means this complete area, multiplied by h square, where h is the constant distance between the two parallel axes. बस इतना सा है आपका पैरेलल एक्सिस थ्योरम. इसका प्रूफ जो है ये आप खुद पढ़ेंगे, मैंने आपके नोट्स में प्रूफ इसका बना करके दिया हुआ है. एंड इफ देयर इज एनीथिंग दैट यू डू नॉट अंडरस्टैंड इन द प्रूफ यू कैन आस्क मी. ठीक है, बट फिलहाल अपन को इस फॉर्मूले की प्रैक्टिस करनी. So let us do it. I will construct a rectangle. I will once again take the value of the sides. Let us say this is 2 meters and this is 3 meters. And I take the centroid of the rectangle. I draw a centroidal axis. I will name it as G, simple G. And I want you to find out the moment of inertia of the rectangle about an axis AB, which is passing through the bottom side of the rectangle and which is also parallel to the previous axis G. So this is a case of parallel axis theorem. So according to parallel axis theorem, what I have to do is my AB will be given by, first I have to calculate the moment of inertia about the centroidal axis. So IG has to be calculated. And if I know what is the value of IG, then I can simply add the value of the product of area multiplied by h square to it, where h is the constant distance between the two parallel axes. Now, first of all, tell me, do you know what is the value of area here? Anybody?
Sir, 6 feet.
It is simply 6 meter square. What is the value of h here?
1.5.
Since this side is 3 meters and G is the centroidal axis, so this centroid must be at a distance of half of 3 from the bottom edge. So this is 1.5 meters. Very well said. So h you already know is 1.5. So this will be 1.5 and we have to square the h, square. So all you have to do is find the value of Ig for which you already have the standard formula and add the quantity of 6 into 1.5 square to it. Now, can you tell me what is the value of Ig first of all? What is Ig?
Sir, 4.5.
To arrive at that, we simply apply the formula BD cube by 12 because this is a centroidal axis. Now the side that will be cubed will be this one because the G axis is cutting the side which has length 3, not the one which has the length 2. So BD cube by 12, if I apply, I will have to put it like 2 multiplied by 3 cube by 12. So this is my Ig. What is the value of this? 2 into 27 upon 12.
4.5.
So you get it as 4.5 is equal to Ig. And A, this, sorry, 6 into 1.5 square is your AH square. So eventually
13.5.
your
Sir,
Ig plus AH square is equal to 4.5 plus 6 into 1.5 square. And this
80
is the value of IAB. Can you tell me what is the unit of IAB?
meter.
No. The
Meter.
unit of meter raised to power 4. This is the unit of area moment of inertia. You always remember. And if you fall into some doubt, you simply check it here. This is area multiplied by the square of distance. Look here. Area is meter square. Again, square of distance is meter square. So meter square multiplied by meter square will be meter raised to power 4. So the unit of area moment of inertia is always meter raised to power 4. Okay. Another question for your practice. This time I am not going to help you. All those who are paying attention, please try to solve this question on your own. A circle has been given to you. This is the center point. A tangent to the circle is drawn at the right hand side. The radius of the circle is given as 2 meters. And considering this tangent as an independent axis AB, find the moment of inertia of the circle about axis AB. Come on, do it quickly. What is the value?
सर आवाज म्यूट हो गया.
ये कैलकुलेशंस मैंने आपके लिए यहाँ पे लिख के छोड़ दी है. आप अपनी कैलकुलेशंस इससे कंपेयर कर लो बिकॉज आई डोंट एग्जैक्टली नो द न्यूमेरिकल आंसर but you just check whether you have arrived at the same calculations or not. See, let me put this question in a very simplistic way as possible. Initially, this was the problem given to you. There was no centroidal axis given. Only the axis about which moment of inertia has to be calculated, only that was given. Okay. But you know that tangents will always be perpendicular to the drawn radius, drawn from the center. Now all you have to do on your own is to create a centroidal axis that will be parallel to the given axis. So what I did was I created a centroidal axis G, but G was not given in the problem. This you have to do it intuitively. Why? Because you know for areas there are two theorems. One is a perpendicular axis theorem and one is a parallel axis theorem. And as you can see that this is a clear application of parallel axis theorem. Once you draw a centroidal axis parallel to AB, the distance h between these two parallel axes simply becomes the value of the radius. It is 2. Now IAB has to be calculated, but IG being a standard formula pi d raised to power 4 by 64, this is already known to you. And since the radius is 2, the diameter will be 4. So pi into 4 raised to power 4 by 64 meter raised to power 4 is the value of Ig. Or in other words, the area moment of inertia of the circle about the G axis is pi d raised to power 4 by 64. Now all you have to do is add the value of AH square to this Ig. And H is the distance between the two parallel axes, which is again 2. Area is pi r square. So once you have area and H, you calculate the value of AH square, add it to your pi d raised to power 4 by 64, and this should give you the answer IAB. So did you understand the application of parallel axis theorem or not? Please tell me.
Yes, sir.
Yes,
Okay.
sir.
If you have understood
Yes,
the
sir.
application of parallel axis theorem, then we can move on to more complicated topics which involve finding the moment of inertia of composite sections. Now, this is a very important topic. The next topic, that is the moment of inertia of composite sections. We have already done some questions related with finding the centroid of composite sections. Now, when a question of moment of inertia arises, the big problem that you guys will be facing is it will be a combined question of finding the centroid as well as finding the moment of inertia. Because in most of the cases, RTU will give you a problem in which first you have to find the centroid and then create a centroidal axis and then find the moment of inertia. So that becomes a big problem for you. Now let us take a simple problem and understand how to do this. But the interesting thing is, once you have understood the concept of parallel axis theorem, the whole exercise should be easy, although it is time consuming to some extent. So I have already copied the problem for you. Here. This is the problem. You can see a T-shaped section. The dimensions are, the top of the T is 10 centimeters. This is 2 centimeters. This thickness is 2 centimeters. The overall height of the T section is 10 centimeters. So that makes this particular length as 8 centimeters. This length. This is 8 centimeters. But what is asked in the question? Let us check out. It says, determine the moment of inertia of the section about the horizontal and vertical axis. passing through the center of gravity of the section. Okay, so moment of inertia about horizontal axis is required and vertical axis is required, but horizontal and vertical axis, where I can draw a horizontal axis like this, anywhere. I can draw a horizontal axis here. I can draw a horizontal axis here. And similarly, I can draw infinite number of vertical axes passing through the area at any point that I desire. But which horizontal and vertical axis is the question setter asking you to find? It is asking you horizontal and vertical axis passing through the center of gravity of the section. यानी कि पहले आपको इस पूरे सेक्शन का सेंटर ऑफ ग्रेविटी फाइंड करना पड़ेगा, जो कि तकरीबन यहां कहीं मिलेगा आपको. दिस विल बी द सेंटर ऑफ ग्रेविटी. हाउ एम आई श्योर दैट it will be some location around here? Because a T section is symmetrical about the y axis. The first thing that you should remember, T section जो है वो अपने y axis के about symmetrical होता है. तो यानी कि अगर आप एक T के बिल्कुल बीचों बीच से एक एक्सिस बना दें, तो फिर उसके लेफ्ट साइड और राइट साइड के सेक्शन इक्वल इन एरिया होंगे. बट अ T सेक्शन इज नॉट सिमेट्रिकल अबाउट द x एक्सिस. x एक्सिस के ऊपर तो आपको ये T शेप मिल रहा है और नीचे सिर्फ एक खाली डंडा मिल रहा है. तो इसीलिए x एक्सिस के अबाउट तो सिमेट्री T सेक्शन की होती नहीं है, लेकिन y एक्सिस के अबाउट सिमेट्रिकल है. सो आई कैन से वन थिंग फॉर श्योर कि ये जो y एक्सिस है, इस y एक्सिस के ऊपर ही कहीं ना कहीं पर इसका सेंट्रोइड मुझे मिलेगा. ये तो पक्की बात है. ये इंटेलिजेंस आपको यूज करनी है, क्योंकि इस तरह की इंटेलिजेंस को यूज करने से आपका एग्जाम में काफी टाइम सेव हो जाएगा. नाउ द अदर थिंग इज, अब इन सारी पॉसिबल लोकेशंस में से एक्चुअल सेंट्रोइड कहां होगा? मेरे को ये पता है कि नीचे से अगर मैं देखता हुआ चलूं, यहां पर आकर के खड़ा हूं तो दोनों साइड सिमेट्री, यहां आके खड़ा हूं तो दोनों साइड सिमेट्री, यहां आके खड़ा हूं दोनों साइड सिमेट्री, यहां पे खड़ा हूं दोनों साइड सिमेट्री. लेकिन जब मैं ऊपर आता हूं तो अब यहां पर सिमेट्री तो है, लेकिन एरिया चेंज हो गया. इस पॉइंट पे मेरे को बहुत छोटा सा एरिया लेफ्ट में और छोटा सा एरिया राइट में मिल रहा था, लेकिन इस पॉइंट पे आने के बाद से मेरे को लेफ्ट और राइट में ज्यादा एरिया मिल रहा है. सो दैट मीन्स मोर एरिया इज अवेलेबल एट द टॉप साइड. तो इस कारण से मैं एक गेस ये लगा सकता हूं कि इस टी शेप का अगर टोटल हाइट 10 है, तो इसका सेंट्रॉइड 5 पे नहीं मिलेगा मुझे, 5 से थोड़ा ऊपर मिलेगा, क्योंकि ऊपर की तरफ भारी एरिया ज्यादा रखा हुआ है. तो दिस इज द लॉजिक आई एम यूजिंग टू अप्रोक्सीमेटली गेस दैट द सेंट्रॉइड विल बी समवेयर around here. That means near to this upper part. But on the other hand, if I give you an I section, I sections देते हैं कई बार. I section ऐसा दिखता है आपको, देखिए, this is the I section.
सर उसमें x एक्सिस के लॉन्ग सिमेट्री होगा.
उसमें x और y दोनों के प्रति सिमेट्रिक होगा. आई एम जस्ट ड्रॉइंग अ रैंडम I सेक्शन. देखो, नीचे वाला पार्ट थोड़ा सा बड़ा बनाया है, ऊपर वाला पार्ट थोड़ा सा छोटा बनाया है जानबूझ करके. बट आई कैन से दैट दिस विल बी परफेक्टली सिमेट्रिकल अबाउट द y एक्सिस. ठीक है, बट नॉट अबाउट द x एक्सिस. क्यों? क्योंकि x एक्सिस अगर मैं इस I सेक्शन के बिल्कुल सेंटर पे एक एक्सिस बनाऊं और मैं बोलूं कि ये ऊपर वाला पार्ट और नीचे वाला पार्ट सेम है, तो ये सही होगा क्या? नहीं होगा. सो x एक्सिस की अबाउट सिमेट्री I सेक्शन इस वाले में नहीं मिली. बट इफ आई ड्रॉ द I सेक्शन विथ बोथ द अपर पार्ट्स इक्वल इन साइज, अब ऊपर और नीचे के दोनों पार्ट्स को मैंने इक्वल साइज बनाया है. नाउ इन दिस केस माय सेंटर ऑफ ग्रेविटी विल बी एग्जैक्टली एट द सेंटर ऑफ द हाइट एंड एग्जैक्टली in the middle here. So I can say that if this is my area, then this is my centroidal x axis and this is my centroidal y axis. ये कह सकता हूं. इस केस में अगर मेरा आई सेक्शन ऐसा है तो ये एक्स एक्स मेरा सेंट्रोइडल एक्सिस तो नहीं हो सकता, लेकिन वाई वाई जो है ये जरूर सेंट्रोइडल होगा। ठीक है, नाउ इफ आई कम बैक टू माय टी सेक्शन, again I will say that this axis yy is my centroidal axis, but what about the centroidal x axis? तो अब आपको सबसे पहला काम तो क्या करना पड़ेगा, इसका x बार कॉमा y बार निकालना पड़ेगा, यानी कि इस सेंट्रॉइड को लोकेट करना पड़ेगा कि भाई ये है कहां पे, और उसके बाद में कहानी स्टार्ट होगी मोमेंट ऑफ इनर्शिया की। तो अब ये पार्ट आपको ऑलरेडी करना आता है, तो इसके लिए क्या करना पड़ेगा, टी सेक्शन चूंकि वाई एक्सिस के सिमेट्रिकल है, सो द फर्स्ट थिंग दैट यू शुड डू इज लाइक दिस। फर्स्ट ऑफ ऑल ड्रॉ अ वाई एक्सिस एंड टेक दिस पॉइंट एज द ओरिजिन। ये जो पॉइंट है इसको ओरिजिन सेलेक्ट करो। ओरिजिन का मतलब यहां पर x, y कोऑर्डिनेट की वैल्यू होगी 0,0। इस पॉइंट को ओरिजिन लेकर के अगर मैं आपसे पूछूं कि व्हाट इज द वैल्यू ऑफ x बार, क्या मेरे को कोई फटाक से इसका आंसर दे सकता है क्या बिना कैलकुलेशन किए?
सर 0।
वेरी गुड, x bar is 0 because you know that this axis is the axis of symmetry। तो इसका मतलब है कि x के डायरेक्शन में ना तो लेफ्ट साइड में आपको सेंट्रॉइड मिलेगा ना राइट साइड में मिलेगा, इस लाइन के ऊपर ही कहीं सेंट्रॉइड मिलेगा। और y एक्सिस के ऊपर जो कि ओरिजिन से पास हो रहा है, अगर मैं कोई सा भी पॉइंट ले लूं, कोई भी पॉइंट अगर y एक्सिस पे लूं तो उसकी x वैल्यू 0 ही मिलेगी। तो इस लाइन पे सेंट्रॉइड कहीं पर भी होने दो, ये तो गारंटी हो गई कि x बार तो 0 ही है। अब मेरे को एक ही चीज पता करनी रह गई, y बार। और y बार पता करने के लिए अपने पास में दो एरियाज हैं, एरिया नंबर 1, एरिया नंबर 2। ठीक है, और इंडिविजुअल एरियाज की सेंट्रॉइड्स आपको x स्टार y स्टार से पता करनी है, जो चीज मैंने आपको बहुत पहले समझाई थी। सो यू गो बैक टू द कॉन्सेप्ट्स ऑफ x स्टार y स्टार, और उसके बाद आपका जो फाइनल y बार है वो कैसे निकलेगा, दिस विल बी फाउंड बाय a1 इंटू y1 स्टार प्लस a2 इंटू y2 स्टार होल डिवाइडेड बाय a1 प्लस a2। इस फॉर्मूले को लगा करके आपको y बार मिलेगा। ओके, एनीवे, ये जो प्रॉब्लम आपको मैं यहां पे दिखा रहा हूं, दिस प्रॉब्लम इज प्रॉब्लम नंबर 9.14 फ्रॉम आर के बंसल। आर के बंसल की बुक है, आर के बंसल की बुक के प्रॉब्लम नंबर 9.14 है ये वाला, एंड दिस इज अ सॉल्व्ड प्रॉब्लम। सो यू कैन सिंपली गो टू द टेक्स्ट बुक दैट आई हैव ऑलरेडी सप्लाइड टू यू, और इसकी डिटेल्ड सॉल्यूशन और ये y बार कैसे आया ये सारी कैलकुलेशन आप वहां पर देख सकते हैं। ठीक है, बट फॉर नाउ आई एम सप्लाइंग यू विद द वैल्यू ऑफ y बार। तो y बार की जो वैल्यू है वो मैं आपको ऑलरेडी दे देता हूं, बट लेट मी जस्ट क्लीन द स्लेट हियर। ओके, y bar is 6.78 centimeters, and please remember that our origin was here. This was your origin. So if y bar is 6.78 centimeters, that means you have to measure upwards. ऊपर चलना पड़ेगा 6.78 सेंटीमीटर तक, क्योंकि पॉजिटिव आया है y bar. So this is somewhere around here, let us say. So this is your centroid. And now we come back to the question. The question says, find the moment of inertia of the section about the horizontal and vertical axis. तो दो axis के about I निकालना है, I xx और I yy. But those axes have to pass through the center of gravity of the section. तो ये कंडीशन आपकी दे रखी थी, इसीलिए पहले अपन ने सेंट्रॉइड पता किया. एंड नाउ once the centroid is known to you, now you draw an xx line like this. This is your xx and this is your yy. Because now you have identified the centroid. So once you have identified the centroid, you draw the ixx and draw the yy axis and the xx axis. Now what you have to do is apply the formula for the total moment of inertia. Now let us come to the concept of total moment of inertia. What is the meaning of this? If I give you multiple sections and ask you to find the moment of inertia about any axis. For example, I give you an axis like this. And I say there is a rectangle here, there is a circle here, and there is a square here. The diameter of the circle is d is equal to 1 meter. The dimensions of the rectangle are 1 by 2. The dimensions of the square are 1 by 1. Find the moment of inertia of the three areas combined. So I will simply name these as area number 1, area number 2, and area number 3. And I will say that since you are asking me to find the moment of inertia of all the three areas about the same axis AB, so IAB will be the moment of inertia of the first section about AB plus the moment of inertia of the second section about AB plus the moment of inertia of the third section about AB. So all you have to do to find the combined moment of inertia of composite sections like this is to simply add the moment of inertia of individual pieces. So I will simply say, what is the moment of inertia of the rectangle about AB? Since I see that it is already passing through the centroid, so I don't have any problem. I can simply apply the formula. What is I1AB? I will simply apply the formula of BD cubed by 12. And which side will be cubed? The side 1 will be cubed. So I will simply write 2 into 1 cubed by 12. This is the moment of inertia I1AB. Now again, I have to find the value of I2AB. This is a circle. And fortunately, this axis AB is passing through the centroid. So it is very easy. I will simply say pi d raised to power 4 by 64. And since my d is 1, I will simply replace this d with 1. So pi into 1 raised to power 4 by 64. This is my I2AB. And the bottom area is a square. And again, this is passing through the centroid of the square. So my I3AB will be equal to 1 into 1 cubed by 12. Since you know that squares are also rectangles, So you don't have to make a new formula for a square. You just simply apply the same formula of I as that of a rectangle. So this is also BD cubed by 12. But the only difference is that B and D are the same for a square. So you can take any side as D and any side as B. It will not make any changes. So 1 by 1 is the dimension of the square. So it is the area moment of inertia of about AB is 1 into 1 cubed by 12. And now since you have all these three moments of inertia, I A1B, sorry, I1AB, I2AB and I3AB, you simply add them up together and you will get the moment of inertia of the complete section about AB. Now this is the general rule that you have to apply here also. How many areas do you see? You see area number 1 and you see area number 2. Now all you have to do is find the moment of inertia of the first area about the centroidal axis XX. Add it with the same thing done to the second area. So again, you go to the second area and find its moment of inertia about the XX axis. You add this and you get the moment of inertia of the complete composite section about I axis. And similarly, for finding the value of moment of inertia of the complete area about the y axis, you find the moment of inertia of the first area about the y axis. You find the moment of inertia of the second area about the y axis. Add them both together, you will eventually get the moment of inertia of the complete section about the y axis. And in a similar fashion, before going to the solution of this problem, let me just give you another intuitive knowledge about missing areas. Suppose I give you a problem like this, a rectangle, which is a complete area, and then I cut an area in the shape of a circle from the rectangle. The area that is available to you is only that part of the rectangle which is not included in the circle. So the circular hole is there. Okay. Now I ask you, find the moment of inertia of the composite section about the y axis. What will you do? No problems. You take the area of the rectangle as area number 1 and you take the missing area of the circle as area number 2. And now all you have to do is
सर रेक्टेंगल के एरिया में से वो माइनस करना।
Yes, find the moment of inertia of the complete rectangle, that is area 1 with respect to y-axis, and subtract, because now this is a missing area, subtract the moment of inertia of the first stage of the second area, that is the circle, again about the y-axis. And this will give you the moment of inertia of the remaining area about the y-axis. So this is the simple concept that you have to apply. Now, what are we going to do here? Look here. This is our problem. We are dealing with this problem right now. Okay. So what I will do is, first I will try to find out I1xx. So that means I have to find the moment of inertia of this rectangular area about which axis? About this xx axis. And can you see the application of parallel axis theorem here? You have to locate the individual centroid of area 1, which will be somewhere around here. So this is the line, centroidal line of the first area. And this will become the constant distance between these two parallel axes. And now you can use your logic to find out what is the value of h, because all the dimensions are given in the problem. So you apply parallel axis theorem to find I1xx about this axis. Again, for finding I2xx, you go to the individual area number 2. This is individual area number 2. And see where the individual centroid of 2 is. It will be somewhere around here. That means at the middle of this height. So I am putting the individual centroid of area 2 here. Again, you draw a horizontal line passing through the individual centroid. And now this becomes the constant distance between these two parallel axes. So again, parallel axis theorem will be applied for area number 2. So essentially what you are doing is apply parallel axis theorem for area number 1 and find the moment of inertia of area number 1 about the x-axis. Again, come to area number 2 and apply parallel axis theorem on area 2 by taking the centroid of the area 2 itself and find the moment of inertia of this area about x-x axis. And once you have obtained these two, you add them up together to get the moment of inertia of the composite section about the x-x axis. And this is what exactly you have to do for y also. ठीक है, ये चीज आपको समझ में आई कि नहीं आई, ये बताओ मेरे को. If this is not much clear to you, समझ में आ गया आपको?
Yes, sir.
And if you are not confident, we can take this example in the next class and explain this in a complete elaborate fashion. लेकिन मैं आप लोगों से एक ही रिक्वेस्ट करूंगा, क्योंकि अपने पास सिलेबस बहुत ज्यादा है और हफ्ते में 3 ही क्लासेस मिलती हैं और ऑनलाइन होने के कारण स्पीड अपनी काफी हिंड्रेंस में आ जाती है. स्पीड बहुत कम चल रही है अपनी, क्योंकि मेरे को यहाँ पर माउस से फिगर्स बनाने में बहुत प्रॉब्लम होती है. माय राइटिंग स्पीड इज आल्सो वेरी लेस. अगर अपने पास एक चौक और बोर्ड होता तो इससे काफी फास्ट काम चलता. बट एनीवे, if you guys tell me that I have to explain, then I will solve this complete problem in a very systematic and structured manner and display it in the next class. But before that, please go to the book R.K. Bansal, take the R.K. Bansal book, go to problem number 9.14. The complete solution is given in very, very minute detail in the book already. So try to understand this problem from the book. And if it is not clear to you, then you please tell me. Anybody can send me an SMS or a WhatsApp message or put a classroom message. By any means, you just let me know कि सर ये problem मेरे को ज़्यादा clear नहीं हुई है, तो मैं अगली क्लास में इसको पूरा elaborate करने को तैयार हूँ. But if you do not tell me, I will skip this part and assume कि मैंने जितना explanation यहाँ पर कर दिया है, parallel axis theorem वगैरह लगाना है, eventually I xx I y आ जाएगा आपका. तो मैं ये मान लूंगा अगर आपकी तरफ से कोई रिस्पॉन्स नहीं आता तो ये मान लूंगा कि आपने समझ लिया है. एंड देन आई विल मूव ऑन टू द नेक्स्ट टॉपिक. ठीक है, तो सी मोमेंट ऑफ इनर्शिया ऑफ कंपोजिट सेक्शंस से रिलेटेड आपको प्रैक्टिस प्रॉब्लम्स मैंने यहां पर दे रखे हैं. सो प्लीज ट्राई टू सॉल्व दीज प्रैक्टिकल प्रॉब्लम्स बाय योरसेल्व्स एंड देन चेक द आंसर. ये सारे सॉल्व्ड हैं, बस ये एक अनसॉल्व्ड क्वेश्चन है. लेकिन अगर आप ये 4 क्वेश्चंस की प्रैक्टिस कर लोगे तो ये 5वां आप अपने आप आंसर निकालने की कैपेबिलिटी रख पाओगे. नाउ अनदर टॉपिक इज मोमेंट ऑफ इनर्शिया ऑफ सॉलिड बॉडीज. ये जो टॉपिक है इसके लिए मैं आपको एक रिकॉर्डेड लेक्चर भेजूंगा. ये मैं रेगुलर क्लास में नहीं करूंगा. अगली क्लास में अपन नेक्स्ट टॉपिक पे जाएंगे. मोमेंट ऑफ इनर्शिया ऑफ सॉलिड बॉडीज क्लास में डिस्कस नहीं होगी, लेकिन जिस तरह से आपको वीडियो रिकॉर्डिंग्स मिल जाती है मेरी, तो मोमेंट ऑफ इनर्शिया ऑफ सॉलिड बॉडीज पे मैं एक लेक्चर अपने यहाँ पे रिकॉर्ड करके आपके क्लासरूम में पोस्ट कर दूंगा. तो ये लेक्चर अटेंडेंस के बिना होगी और रिकॉर्डिंग आपके पास आ जाएगी और ये रिकॉर्डिंग आपको देख करके खुद पढ़नी है. सो दिस इज सम न्यू ट्रिक्स दैट वी हैव टू अप्लाई इन दिस सिनेरियो ऑफ ऑनलाइन क्लासेस, क्योंकि अपनी स्पीड बहुत कम चल रही है और सिलेबस बहुत ज्यादा बड़ा है मैकेनिक्स का और खत्म ही नहीं होगा आपका. तो ऐसे कुछ काम करने पड़ेंगे आपको भी एडिशनल टाइम निकाल करके. मैं जो ऐसे एडिशनल वीडियोस भेजूंगा आपको वो देखनी पड़ेंगी. ठीक है, डू यू एग्री विद दिस और नॉट?
Yes, sir.
Yes, sir.
ठीक है, एक सेकंड में आपकी अटेंडेंस ले लेता हूँ, प्लीज डोंट गो अवे।
Yes, sir. Yes, sir.